Hello everyone, good evening. This is Sangeetha, Assistant Professor, ECE Department, SNS College of Engineering, Coimbatore. So in the last video, we discussed about the image compression, the basics of image compression and types of image compressions, that is lossless or lossy compression, and the coding techniques used for image compression, that is wavelet coding, transform coding and run length coding. So in this video, we are going to see about image segmentation and detection of isolated points and line detection. So let us start our discussion with the basics of image segmentation. So image segmentation is a crucial step in an image. So in image segmentation, it subdivides an image into smaller images or regions. So the main objective of image segmentation is to simplify its representation or to make further analysis easier. So each segment typically represents a specific object or a region with similar attributes such as color, intensity or texture. So segmentation is a vital pre-processing technique for various applications like object detection, object recognition and medical imaging and satellite imaging. So the main goal is to partition the image into regions that are homogeneous with respect to certain properties while minimizing the variance with each region. So there are types of segmentation techniques. The first one is the thresholding based segmentation. This is one of the simplest and most commonly used techniques. It works by selecting a threshold value that distinguishes objects from the background. So, and next one is edge-based segmentation. So, edge detection is used to identify the boundaries between the different regions. So, this method relies on detecting discontinuities in the image intensity. And region-based segmentation, the other type of segmentation, and clustering-based segmentation, model-based segmentation and deep learning-based segmentations are the different types of segmentations. And the main applications of image segmentations are medical imaging. So in medical imaging, it is used to detect and segment organs, tumors or in CT and MRI scans. And in object detection, it is mainly used to identify and locating objects in the scenes for autonomous vehicles, robotics and security systems. And coming to the satellite imaging, segmenting landscapes into different regions like forest, water bodies and urban areas. And in face detection, it is mainly used to identify facial regions for face recognition systems. And in document image analysis, segmenting text tables and images in scanned documents. And the next we'll discuss detection of isolated points. So detection of isolated points is an important operation in an image analysis. It is often used in the context of noise detection, defect detection in industry inspection and outlier detection in image processing. So the isolated points refers to pixels in the image whose intensity differs significantly from the surrounding pixels. There are outliers or noise and it can be detected using techniques that examine the neighborhood of each pixels. So the main equation is dou square f of xy is equal to dou square f divided by dou x square plus dou square f divided by dou y square, where the partials are obtained from the above equation, that is dou square f of x comma y divided by dou x square, that is equal to f of x plus 1 comma y plus f of x minus 1 comma y and minus 2 f of x comma y, and dou square f of x comma y divided by dou y square is equal to f of x comma y plus 1 plus f of x comma y minus 1 minus 2 f of x comma y. So then we have to take the Laplacian, and after taking Laplacian, the equation becomes dou square f of x comma y is equal to f of x plus 1 comma y plus f of x minus 1 comma y plus f of x comma y plus 1 plus f of x comma y minus 1 minus 4 f of x comma y. So this is one of the simpler methods to detect isolated points. by using a difference measure that compares the pixel's intensity with averaging the intensity of its neighborhood pixel. For a pixel f of x comma y at coordinates x comma y, its intensity is denoted as f of x comma y. So the neighborhood of pixels can be defined as set of the pixels around p of x comma y. So the interpretation of results, by applying this method, the isolated points in an image can be identified and flagged as potential noise or defects. These points may be smoothed out or corrected using filtering techniques or replaced with average of neighboring pixel values. So the threshold T must be chosen carefully based on the image characteristics and noise levels. So the image segmentation plays a crucial role in various fields by breaking down images into manageable pods for further analysis. So these techniques vary from simple thresholding to complex deep learning based models depending on the application. And the detection of isolated points mainly helps to identify anomalies or noise in an image by comparing each pixel to its neighborhood. So by setting an appropriate threshold, such points. Hope this video will help you to understand the basics of segmentation. Thank you.